Solutions for assignment 2. Question 1, question 2, directly from the notes. But be very careful. Question 1, if you're asked to outline Einstein's explanation of the photoelectric effect, you need to full outline. Okay, so the 5 points in his explanation. So check those in your notes, not just the definition. And question 2, if you're ever asked to describe an experiment, it's always better to draw a label diagram. It makes life easier for you. Okay, now the rest of the questions are all calculations, and let's have a look at what we need to do. So first of all, you have page 46 to 47 open, and you need to be clear that you have on in those pages H, so you always have H, you always have C, we'll be using those a lot. You have E, for 1.6 by 10 to the minus 19, that's what you use to change from electron volts to joules. And you also have, and some people miss this, you have ME, the mass of the electron, which we need in question 6 and question 7, as we'll see. Okay, so I have 3 and 4 completed here. So question 3, you were looking for the energy. You had F, and you obviously have H, so E is equal to HF, and directly, and you got your answer 1.62 by 10 to the minus 18. Question 4, okay, again, you were given, you were asked for the energy, so you needed to finish with E is equal to HF, okay, which we have here, right, but you have, you don't have F, so we had to go away and get F using C is equal to F times lambda. Okay, so I think that was reasonably well done and reasonably straightforward. Then question 5, 6 and 7 all involve using the Einstein's photoelectric equation. So question 5 was the most straightforward, okay, in that you pretty much had everything that you needed. So you were given the work function, okay, so 4.64 by 10 to the minus 19 in joules, so you're in business. Okay, you were given the frequency of the incident light, 7.57 by 10 to the power of 14. Okay, you're asked for the kinetic energy, we'll just write that as half mv squared and put it into a bracket. We're just looking for all of that together. Okay, you were given H, okay, you know I have H and I have C, which will be helpful to us. Right, so it's Einstein's photoelectric equation, so we write that down. Okay, and remember all we're looking for is that, okay, this. So all we need is HF and 0 and phi, and we have all of those. So we fill them in. So 6.63 by 10 to the minus 34 times the frequency, 7.57 by 10 to the 14. Okay, equals the work function, 4.64 by 10 to the minus 19, plus a half mv squared. Tidy it up on the left, okay, and subtract the 4.64 by 10 to the minus 19, and you end up with a value of a half mv squared equals 3.79 by 10 to the minus 20. Now, if you're making a mistake of going from this line to this line, and some of you are, you must refer to that maths tutorial. Okay, so it's in your notes. Refer to the maths tutorial and make sure you understand where you were going wrong. I won't go into detail here at the moment. Question 6. Okay, so question 6. It's the same question, except you aren't directly given HF and phi, so you had to get some of them. Okay, so question 6, you were given the work function as 4.32 electron volts. So you know you have a problem there. Okay, we'll deal with that in a minute. You were given the wavelength as 286 nanometers. Okay, step 1, we change that to 286 by 10 to the minus 9. Right, and then we were given H. Okay, we had H, which we'll need, we had C, which we'll need, we have E, which we'll need, and we have M, which we'll need. So we have everything else. Okay, so the first step was to find the work function in joules. So remember, to change from electron volts to joules, you multiply by the charge on the electron, which is in your tables. Okay, and you got an answer of 6.91 by 10 to the minus 19. Okay, part 2, right, we needed to get the frequency. So as we did in question 4, we're just using C as F lambda. So C from our tables, F we're looking for, and then the wavelength 286 by 10 to the minus 9. So by rearranging, and again check the maths tutorial if you're in trouble, by rearranging you end up with F as 1.05 by 10 to the 15 hertz. Okay, question 3, or part 3 then, is to find not the kinetic energy, but actually the velocity this time. So we need to find V. Excuse me. Okay, we need to find V. So if HF is equal to phi plus a half mv squared. So we're now in business because we have everything else. 6 by 10 to the minus 34 times the frequency, which is 1.05 by 10 to the 15, equals the work function in joules, 6.91 by 10 to the minus 19, plus half times the mass, 9.11 by 10 to the minus 31 v squared. Okay, so we get 6.96 by 10 to the minus 19 equals 6.91 by 10 to the minus 19 plus 4.55 by 10 to the minus 31 v squared. Okay. We then rearrange, okay, and you get a value for v eventually, okay, of 1.05 by 10 to the power of 5 meters per second. If some of you rounded, you would get answers a good bit away from that. If you rounded in different ways, you would be given full credit as long as you don't go mad on your rounding. Okay, and again, check the maths tutorial if you're having trouble going from the second last line to the last line. I'm just writing the final answer here. Check the tutorial if that's not clear to you. Hugely important. Question 7. Question 7 was effectively the same question, except you were given you weren't walked through it. You weren't told the little bits. You had to figure them out yourself. But it was actually the same question. So let's have a look. So 300 by 10 to the minus 9. Okay, and again H, C, E and M, you're given all of those. Okay, right, now what we'll normally do if we get an electron volts, we'll just make the change here rather than doing it separately. So right, you just multiply by that and we get 3.66 by 10 to the minus 19. Okay, now the only extra thing we need, we know we're going to have to get the frequency, so we know, okay, we're doing this all the time. Just getting so repetitive. Okay, has to be done. Okay, and we end up getting a value of the frequency 1 by 10 to the power of 15. Okay, and then finally we're back to the fourth electric equation. Okay, so 6.63 by 10 to the minus 34 by the frequency, which is 1 by 10 to the 15, equals the work function 3.66 by 10 to the minus 19, plus a half of the mass of the electron by v squared, and we end up getting an answer of v as 8.08 by 10 to the power of 5. Now, I'm going to reiterate it once more. If you're getting it right to the second last line and you're getting it wrong after that, you're going to go and look at that maths tutorial and you're going to figure it out. And if you're still not sure, you're going to message me. Okay, it is of huge importance. You're all getting the physics right, and then it's terrible to waste it on making basic errors regarding linear equations. All right, so that's assignment 2 sorted. Thanks a million.